stars, unicorns, or any other floating things in the sky.
Okay, how about this?
You can have some more and make it a game.
Game on!
Or if you can fly alongside the Powerpuff Girls. You could add your whole crew. Now, you've created your own flying animation, just like a Cartoon Network animator. This is only the beginning. What things will you make fly? When you get creative in Scratch, there's no limit to your imagination.
You never know until you try.
To get started, follow the steps in the tutorial by clicking the blue button. When you're done, share your project with friends in the Scratch online community. Check out what cool stuff other people are making too.
So, as you can see, this is clearly not meant for your age group, but it's a great video that gets kids excited. And another thing it really points out is that for Scratch, you can have a very simple tutorial, but there's just so many things that students can do with the basic guidelines that you're given. So you can maybe make the Powerpuff Girls fly, but you can also add whatever you want. You can change the things with their flying path, so it's just very. There's just a lot of room for creativity for individual students, which is nice, even for a tutorial that has a lot of guidelines in it. So now I'm going to go through, I'm just going to show my code for this tutorial that we just did. So expand it. So I made the most basic version possible of this Scratch tutorial. So just to talk about some of the components. So you can see over here is the block side and over there is the user interface. And then down here is the sprite. So the sprites are basically anything that's moving in the screen. And you can see the code for each sprite. So right now we have the cat code over here, but then I can click on the buildings and there's the different blocks, the clouds, and it's a different block. You can also set the background right here, and you can actually set the background to change as well, which is cool using other blocks. But it's just really simple because if you want to change something with the cat, just click on it and there's your blocks. Another really nice thing is when picking the blocks that you want, they're really split up into categories. So events you can use to very clearly specify when this happens, do this. So it's easy to teach a lesson on paying attention to how to have your code sort of be constantly listening for certain events because it's clearly one section of the user interface that you can introduce all at once. Similar things in control. So control has your if-else loops, it has your loops, it has your if-else conditionals, and it's all in one place. So really easy to point out what this is, and it looks very similar actually to real code, which is nice. Having if and else versus in code.org, some of the blocks tend to be more when this happens, which is less how code looks when you start writing it out. So that's pretty nice, and then you can also really change the looks. You can have the looks constantly changing. You can have the characters say things. Another thing that you can do is with costumes. So, for example, this cat right now, it looks like this, but there's also another costume or another version of the same cat, so that you can set, there's blocks in here that you can have it, for example, say next costume. So right now, if I run it, every time I hit the up button, it will change costumes. And right now I have it, so I can press the up arrow and down arrow and move back and forth. So there's integration with the keyboard, yeah.
Is there somewhere that you could give, or I could find the lingo? Because you're using words.
Oh, sorry.
No. Because I'm a beginner.
Yeah.
So, but so that I know that, okay, if I say costume, it means this. Because even the word code, when you're saying coding, because that's why I'm here, because everybody's always talking about coding, I'm like, what is that?
Right.
So is there something that explains that? Or
So I guess that would kind of go on the learning curve part, because even for the students, it's really hard to learn the lingo. So what I would say is going through the tutorial.
The answer is yes. Scratch itself has a terms glossary, which I'm on right now.
Oh, okay, yeah.
I mean, you've got 100 words probably, but like the word sprite was a word that I didn't know a year ago, and now I know that sprite means like one of the characters.
Right, so
kinds
that's what
of
I'm
things
saying,
that
and you know, it would be hard for me to teach them, for me to use terminology, and I don't even know what it means
Isn't
myself.
there a basic tutorial on what's happening on the screen too?
Yeah, so that's the next part I'm going to talk about. But
Okay.
the tutorials are really good about showing the blocks, and because everything is color coded and things
Okay.
like that, it's really helpful to go through those. And
Okay, thank you.
it's sort of possible to pick it up, but also having a glossary is great. So, I'll go back to- Yeah, what's great about things like Scratch and Code.org is that they both have a lot of resources for beginners. App Inventor is less tailored to beginners, so they have less resources, but it's still possible to find curriculum worksheets and educator resources. It's just a little bit harder to find. So some available Scratch resources. They have, for every single tutorial that they, that are by like Scratch people and not by the community, because you can also look at community projects and community tutorials, but Scratch itself has specific curriculum resources that they give out. So, and for each of those, they have a tutorial with the video and walk you through step by step. They have activity cards, and then they also have educator resources. So the tutorials look like this on the side, and they have in it, like, build a script like this and show videos of dragging the blocks on, where to go, and then what it does. And so as you scroll down, it will walk you through step by step of one section, which is, this one would be adding color effects. And then you go to the next section and it'll be like, here's how you rotate, or here's how you add a new script. And it will, this video is great on the side because it just shortly, like very clearly tells you, drag here, which I think, I found really helpful. Scratch was actually the first thing that I ever used to learn computer science. And so having a video be like, oh, this is how you add a new character, and pointing it very clearly, it's super helpful. And this is especially good for the students because when they're first getting started, being able to go through a tutorial. But also, because Scratch is great about adding that creativity element, they don't say, you have to add the cat here. They say, add a new sprite. And it allows for a lot more students to change it and make it their own, which is really nice.
Do students have to create their own logins, each one for,
You
how
can,
does that work?
there are teacher accounts and you can create their accounts
Yeah.
from yours.
Is that free? That's free.
It's
Yeah.
all free.
Excellent.
Oh, another really nice thing is because Scratch has so many images already uploaded, students don't need to try to like download images from other places in the web, like right to start out, which just makes everything way simpler because trying to like save images and download and re-upload and save sounds can get really complicated, which is one big issue we've been running into with App Inventor.
Yeah. Especially because Google Chromebooks don't have so much
Yeah.
space to be saving in.
Yeah, and trying to go through Google to find an image can take like 20 minutes for a student to find the perfect image, and
That's
suddenly you've
minimum,
lost.
right?
Yeah, suddenly you've lost your entire class. So being able to just go and easily click. It's also nice, like for example, we can go back to the flying tutorial, but for if I were to want to add a new sprite here, there's actually categories over on the side. So you can see flying, and then they can just go here and all the things you could possibly need for flying are all in one place. And that's just makes it way easier for students to still be creative while having a framework.
Choice.
It gives the sort of idea that there are choices, even though they're still a little bit limited. So, and then of course later you can start uploading your own and make it, like it just becomes very adaptable, which is great.
So are the projects sequenced, like starting out with very basic concepts that they build, or are all of them, like can you do all of this in every project?
Yeah, so you can do all of this in every project, but they also in the educator resources will tell you after you do this tutorial, here is a good one to do next, which is really useful for that. But I will talk about that in the pros and cons, because one problem with Scratch is that they don't specify like, this is a good tutorial to teach if-else statements or to teach loops. And so trying to figure out which one is a good one, they all sort of incorporate every single element, which could be not very beneficial if you're trying to target a specific area. So another thing that Scratch has are activity cards. So these are things that you can either download as a PDF and cut out, or you can also order them, but that you have to pay for. But basically they're cards with instructions. And these are kind of helpful because sometimes for students going through a tutorial is great, but they'll just scroll to the bottom and miss half the instructions in the middle. So having an activity card where they can check things off as they go is really useful. They also have with these activity cards different ways that you can enhance what you've been working on in the normal tutorial. So that's useful for students who are going much faster. They can, once they finish, you can hand them an activity card and tell them, okay, now try this on your own, and it has a little bit less guidance, so that way they are sort of thinking outside the box and doing something while you are helping the students who are still working through the basic tutorial. And then finally, Scratch has educator resource documents. So these have a lot more descriptions about what's going on in the background of each component. So, so it still shows like where the blocks are and also where to go to like click create, choose the letter. So these are much more like laid out instructions and don't sort of leave room for the creativity, but like as educators, like it's up to you to sort of figure out where the creativity can be added in. And it also has like, prompts you can ask students, like which letter do you want to start with? Do you want to animate your name, initials, or username? And things like that can sort of be guiding questions for the students. And then, like I said, they also have at the bottom of like the document, here are the next resources you can use that sort of build on what you learned in this tutorial. So some pros and cons of Scratch. Some pros are that there are a wide variety of project options. There's kind of no limit to what you can build in Scratch. It's also easy to connect to other products. So one product that I'll talk a little bit about in our closing keynote, and it's also one of our sponsors, is Makey Makey. And basically they have a little circuit board that you can use alligator clips to connect to like a banana or like any sort of household item. And those, so you can change it so your space bar is a banana, or you can make your like up, down, right, left keys on your keyboard into like, what was one that I've done? I think I had like some crazy, like I had like apples and like, I don't know, fruits for some reason were like what I was using in this one situation, but people can pretty much use anything. There's a stair piano that someone did with this once, but you can connect it to Scratch, so if you make a game on Scratch, then you can use the banana spacebar to like move your item around, or use the up, down, and connect it to everyday objects, which is kind of fun. And just like, it's like works really well with that product and with similar ones. Another pro is that there's lots of tutorials with detailed instructions that allow for creativity, which is always great. Some cons though are that there are less full curriculum resources readily available. So while there are educated resources for like one day of working in Scratch, they don't really lay out a curriculum for an entire year of teaching computer science. It's also a slightly complicated user interface, as you pointed out. Learning what all the different vocabulary words mean takes time, and for students that might be extremely complicated. Plus this isn't a gamified version of computer science, so they still have to start from a blank canvas, and they still have to add components themselves rather than that sort of immediate satisfaction of finishing. And then finally, Scratch doesn't teach specific concepts, so like one tutorial doesn't teach loops, one tutorial doesn't teach conditionals, one tutorial isn't just a basic like telling the computer what to do. Every tutorial has everything in it, which can be kind of overwhelming, especially at first. So who is Scratch for? It must, like the students that are using it need to be able to read and navigate a complicated user interface. So even though they have these videos for younger students, it might not be super useful for younger students until they learn how to be able to navigate this interface. But there is a lot of project variety, so it can apply to many different ages. Like for example, they could do Powerpuff Girls, or you can incorporate it into maybe your history lesson, or sort of expanding upon it to incorporate into different subjects, which is nice. And another note is that CS50 at Yale, which is the introductory CS course here, actually uses Scratch in their first lesson. So it's really considered a real programming language. You can really build actual games that you can upload to like a website, or you can upload maybe into an app that you could then upload onto the App Store. So you definitely shouldn't think of Scratch as just like an introductory language, even though it sort of is, because it actually can be used in real world situations, which is really cool for your students. And one of the people leading the Code.org workshop, she actually won for the best game in CS50 her year in Scratch, because they did a whole competition of who could make the coolest game. So that's pretty cool. And so yeah, any questions?
So the language that they use in here, the language, you're saying it's much more similar than the code.org?
Yeah, so code.org doesn't have like if else. It will have like when you hit the wall, or when the item is, like when your little guy that's moving around the screen is blue, which isn't super applicable to actual code. Like when I'm writing code, there's no whens involved, it's all if else.
So that's what you really do when you write code.
Yeah.
So if you're learning that vocabulary, then that's vocabulary that if they kept
Exactly.
going, that they would continue to see.
Yeah, so the vocabulary is very similar, which is great. Yeah.
The curriculum is all directed toward middle grades, correct?
Pretty much, I would say it's probably good for like second grade up.
Okay, I mean, there's a big difference between a second grader
Yeah,
girl and a 7th grade boy.
right. But that's the whole point of the, like just how many different options there are for projects. So not only are there the tutorials offered by Scratch, but there are also tutorials offered by other users who
Right.
use Scratch, and they can create their own. So hopefully with Scratch, what you could do is start them on a couple different tutorials that are like offered by Scratch, and then kind of allow people to find their own tutorials to follow, which might allow for greater changes in project ideas.
Okay.
There's also like a whole world of like go into somebody else's Scratch and like mess with it, right?
Yeah.
Like that's one thing that you, right, like, because I know when I press explore, it shows me like the thousands, or if I search for George Washington or Oaxaca, like
Yeah.
it'll show me things that are connected to that, and then I could basically go into somebody else's public one and remix it. Is that what the term?
Yeah, you can like copy it into your own
Uh-huh.
account and then change as much as you want and sort of publish it as your own, which is kind of cool. It's also very similar to the open source community for
Right.
CS later on. So open source is basically this idea that people are putting their code out there because there's just not enough people and not enough coders to do all of the computer science work that people need to be done. And so having things like this allow for sort of students to kind of get involved with the idea of messing around with other people's code, and then later that could turn into actually messing around with people's code in like a nonprofit organization that has so much data and doesn't know how to deal with all the data. Like I could go in and find their data right now and manipulate it, and your students could as well later on.
So like when you say you can search the public Scratch, like if they were studying, say, Earth changes, you
Yeah.
could put that in and it would come up with different types of things that people have come up with to.
Yeah, I bet we could actually do that right now. So I go back to Scratch. So
I've never used it before, so.
yeah, so Earth Day game, save the Earth, why we should save water, saving the Earth. So these are all different Scratch projects that have been done that are related to the Earth. I'm not sure which of these would be the most relevant, but
Right, but you could
Yeah,
take
it's
it.
not very curated, right?
no, it's very much
And
just, there's all these projects, nobody rates them, nobody says like, these are the best projects, you kind of have to filter through them yourself, right?
So like, it's not so simple as saying like, all right, kids, first search for Earth Day stuff and see what's cool. You kind of have to, I mean, again, depending on how tight you want to hold your class, You kind of have to tell them which ones to look at because some of them are super dumb and don't work or were created by some other 8-year-old, which is fine or not. So.
Depends on what you're using it for.
Yeah, exactly. Right. What are you trying to teach?
Well, that's my overall question. What are we trying to get out of this? You know, this is a larger question.
Yeah.
So if they complete something and they make something flying, let's say it's a 4th grade and they make something fly. Okay?
Well then hopefully they would make it into something that they're actually really interested in. So maybe if a student is really interested in, like, when I was in 7th grade, I really wanted to be a Guantanamo lawyer. So maybe I would have made some sort of Scratch application, like, with like updates about what was going on in Guantanamo at the time. And so being able to, and you could do that because you can just add any pictures you want, change it however you want. And so I don't know how that would connect necessarily to flying, but after doing that tutorial, I would know how to use all the different pieces and hopefully build something that was actually really important to me at the time.
Okay.
And then that would eventually connect to later being able to understand that computer science can be applied to everything that you do and to every aspect of the world, and is actually really applicable and useful.
I think that this can help students feel like video game designers. This can help students feel like animators, which for a lot of my students is cool and exciting. It can be a storytelling element, though it takes a long time.
Yeah.
Realistically, like to create a story. If I want, if I want to use like a book report kind of an output, it would be really labor intensive and really time intensive. Because creating anything cartoony is really intense. In its simplest form, it is a way to get students to be able to play around with all those different blocks and understand how they work, which could actually be an interesting intro to a platform like code.org. Actually, it would fly if they had spent legit time on Scratch. I don't know. I have not used Scratch, so I'm thinking without trying.
You've used code.org? Yeah, I've done that one too, and have kids going through the Moana one.
Yeah.
And they're moving, figuring out how to move right, left, repeat 5 times,
Right.
All that kind of stuff. But I'm looking for what's the end game of this.
This is much more like Microsoft Paint. It's
Yeah.
like create what you
Yeah.
want.
So the end result was for, I did some of this last year, just going blank. Somebody said, check this out. And when they would get done, I would put a certificate up on the wall, give them a certificate, put a certificate on the wall, like it was a Hall of Fame there.
Yeah.
This
does not
So
happen.
some kids would walk in saying, how do I get my name up there? And I would say, okay, you gotta go through code.org, but once they get done, for some kids it was like empty. Okay, I did it. Now what?
Yeah, it's sort of, things like code.org to me feel a lot like when you're doing multiplication tables in 2nd grade, and once you're done, what do you do next?
Yeah.
And I think Scratch is more about what you do next because you can go in and then do your own thing. So it's sort of like going from multiplication tables to, now let's multiply my own numbers, and can I connect that to a problem that I actually find really important and relevant? So I guess that's how I would think of Scratch. It sort of is this bridge between the code.org and following this specific lesson, and then actually being able to build your own project about something you care about, which would hopefully translate later into a career.
Yeah, see, I look at this one saying this particular one might interest maybe half the kids, we should help the earth stay cleaner, get better.
Yeah.
So they would dive into one of these and I guess see how that transpires.
And it's fun because you can play other people's games and then see, what was a problem with someone else's game, how can I make it better? So
For all my kids who want to be video game designers, to go to see inside the code of some of these very simple games, and remind students that if I want to be a video game designer, I'm going to have to do a lot of work to understand how this works. That things are really complicated. So it can develop a certain appreciation for that subset of students who are really interested in that world.
So actually, lunch is here. So We took a little bit too much time, but if you want to like pull up Scratch yourself and like check it out while you're doing lunch, like I'll be out there, we'll all be out there, and we can like point things out for you. Otherwise, we're going to give out a list of resources at the end of the day, which will have links.
Great.
I believe that, is it possible to get those and move it up with the other, you know?
Oh yeah, we're going to send everything out at the end.
Oh, okay.
So in the feedback form, it's going to ask for like if you want to be added to a newsletter and various things like that. And if you do that, we're going to be continuously sending out resources as they come to us and all the conference.
If anybody's in, there's another one called Code Monkey.
Yeah, I've never used that. But
It's so simple. This is the one you should look at. Because Code Monkey, it has an icon faced this way, like a monkey faced this way, and the banana's over here. So if you click take 2 steps, it goes in the wrong direction, 2 steps. They have to take it and turn it this way, then you stay 2 steps, and you realize it's not at the banana because it's 5 steps away. So that's as basic as it gets, but there's actually 24 of them. So I forget what your name is, but the one that, the kids that really latch onto it, they want to go through the 24 steps. It makes them go around hedges and across a bridge, and
Thank you.
Yeah.
it's a pretty good one.
I definitely agree with you that platforms like Scratch either require that students have a very particular vision for what they want to create, or that you have a lot of time to like let them explore, or that you're ready to like design a particular project or task, right? Which could be around, if we're reading a book and one of the characters' names is Miguel, and we've already done a project to think about like what are the characteristics of Miguel? How do we describe Miguel? Like what is he like? And now here's a canvas to like animate Miguel, showing those 5 characteristics. So what are things that he would say, or actions that he would do, or where would he go? What background would we put? So those kinds of choices could manifest in a project like this.
Right. Yeah, see, I'm with you on that. The kids I have are a revolving door.
Yeah. So this is not for you. I don't think.
No, I think it is at a certain point.
Yeah.
I need to see the kids that have a little bit of stick to it and
Right.
Correct.
that are,
Yeah, the revolving door is probably better fit through like a code.org,
figured.
but this is better for like
Yeah.
the students
Oh,
who
you
have
did? Okay.
done code.org and are still interested.
hey, question, totally, what happened?
Oh, I'm
I
a marathon
just,
runner, so I overtrained and
very
got almost a
involved
stress
in
fracture,
the
but
community.
not.
So I like the teachers who are
Yeah,
in the
it's
neighborhood.
a good look, not super professional, but yeah, it's a good time.
So when are you back to running again?
January
As an
1st.
after-school club. Someone later
Yeah,
today will be
fingers
talking
crossed.
about what it looks like to have coding clubs. Ask Roy.
Huh?
Ask Roy.
Yeah, I know. I'm swinging. Yeah, all right. Yeah. You will be available to do that?
No.
No?
No.
I mean, you're helping in what sense?
Oh, as in,
Yeah. that would be still going.